Welcome to the PrepNet, presented every Sunday at 6 p.m. Eastern Time on Talk2Me's Channel 14. Come join us to discuss everything about prepping and hear what others have done. All about electricity. Part 9, Lithium Iron Phosphate Batteries, Part 3. We will continue discussing the use of single lithium iron phosphate cells for your battery bank, and we were going to cover how do I build a 12-volt battery from single cells? How can I view the battery's total voltage and the voltage of each cell? And how do I balance the cells in my LFP battery? However, I found that building a 12-volt battery would be enough for one net. We'll discuss the other two topics next week. We will be building a 12-volt battery from single LFP cells, as I didn't want to disassemble one of my working 24-volt batteries for this, but you will get the idea of how to create any size battery. So, how do I build a 12-volt battery from single LFP cells? Obviously, the first step is to get your LFP cells with the same amp-hour rating. I have provided a link to a company I have purchased my LFP batteries from in the video description of our expanded presentation on YouTube. You get good quality, new grade A batteries from them. They also have a warehouse in Texas for many of their batteries. I have also provided the email address of the salesperson I have dealt with. Email her for quotes and to answer questions. She is very knowledgeable and can answer your questions. To let you know how prices have changed, my first 280 amp-hour cells cost me $149 each in April of 2022. Then my second 280 amp-hour cells cost me $80 each in August of 2023. As of November 2025, those same cells are now $52 each, and they have cells with even higher amp-hour ratings. Now to continue, we will be using 95 amp-hour cells for our 12-volt example battery. I recommend getting more cells than what is needed to build your battery or batteries. The example of my first battery bank system was that I got 32 LFP cells, but was only going to use 24 of them to make 3 24-volt batteries. I then had 8 cells left over for spares, and this also helps you match cells for a battery. Verify positive and negative terminals of all cells. Use your multimeter to verify that you know which terminal is the positive and the negative. They are sometimes not marked correctly. Always verify them yourself and mark each terminal if it needs correcting or to make it easier to identify, which will make your battery building easier. Label each cell with a unique identifier. I used numbers, and here is a different example. This will help you manage your cells. Next, check the voltage of each cell with a multimeter. This gives you a baseline for each cell. Put this information into a spreadsheet next to the number of the cell. Now, manually balance all the cells you got, not just the 4 we need for our 12-volt battery example. Connect all of your cells in parallel by connecting all of the positive terminals together, and connect all of the negative terminals together. Let the parallel connected batteries sit for at least 48 hours. This will equalize all the cells to the same voltage. I only showed 4 cells being balanced, as the rest of my cells were already being used somewhere else. Charge the cells. You will need a charger that must be able to charge 3.2-volt cells. You cannot use a 12-volt charger for this. I have put links to chargers that will do this in the video description of this expanded presentation. Connect charger to the parallel cells. Turn on the charger and set the voltage to 3.6 volts using both the rough adjustment and the fine adjustment. Follow the directions of the charger on how to do this. This is called constant voltage or CV charging. This will only apply up to 3.65 volts and no higher. Remember that 3.65 volts is the maximum you should charge these cells. Now connect the variable charger to the parallel pack and charge it. This will charge all of the cells to 3.65 volts, and this may take 1 or more days, depending on how many cells are in parallel. After the current on the charger shows 0 amps, turn off the charger and disconnect the charger. Now disconnect all of the cells and let them sit for at least 24 hours to stabilize. Sort your cells. Now measure the voltage of each cell and log the voltage of each cell in your spreadsheet. For our 12-volt battery, pick the 4 cells that have the closest voltages to each other. If you will be building many batteries, match those that are closest in voltages, even if they are lower voltages. But all cells should be near the same voltage per battery. Now we can build our 12-volt battery. Place your 4 closest voltage cells on your workbench so you can easily connect them in series to make a 12-volt battery. Place cell 1 with the negative terminal at the top. Then, place cell 2 next to it with the positive terminal at the top. Place cell 3 with the negative at the top, and cell 4 with the positive at the top. Now, to connect them into a 12-volt battery. Carefully install the provided bus bar between cell 1 positive and cell 2 negative. Next, install a bus bar between cell 2 positive and cell 3 negative. Finally, install a bus bar between cell 3 positive and cell 4 negative. Be sure to tighten the terminals to the torque specification of the cells. You now have a 12-volt battery built from 4 LFP cells. To verify this, measure the voltage of the battery between cell 1's negative terminal and cell 4's positive terminal. The measured voltage should be between 12.5 volts and 14.2 volts for a normal 12-volt system. If less than 12 volts, recheck that you have properly connected the cells in series. For added stability, you can tape the 4 cells together so they don't spread apart and loosen the terminal connections. Warning: when we finish building the 12-volt battery, the installed bus bars are not protected. This makes it very easy to short your battery with something falling on it, like a screwdriver, and cause a fire. Be sure to cover the top of your exposed cell connections with an insulating material like plastic or rubber. A note here: all connections in your complete solar installation should be connected with the shortest possible lengths of wire. You can now charge this 12-volt battery with the proper 12-volt charger by connecting the charger's negative clamp to cell 1's negative terminal and the charger's positive clamp to cell 4's positive terminal. You don't need to charge each 3.2-volt cell individually. Remember to watch the expanded presentation on our YouTube channel, which will have visuals for better understanding. Next week, we'll continue our All About Electricity series and discuss how can I view the battery's total voltage and the voltage of each cell, and how do I balance the cells in my LFP battery. If you have any questions about what we have discussed here tonight, please send your question to prepnetch14@gmail.com and enter question in the subject line.